Welcome to Additive Manufacturing.
Oh, hey. Thanks for being here. This is our submission for the Vermont State University Additive Manufacturing team, Just Press Print. Let's meet the team.
Hey, that's us.
Fraser Pierpont is the additive design and printing technician. Mike DiPano is a lab technician with 25 years of manufacturing experience. Isabella DeCandio, that's me, is our quality technician. Gabe Hill is our subtractive technician. And James Kelly has many years of mechanical experience. Okay, now that you know everyone, let's get down to business. We wanted to create a multi-tool that would fulfill all the parameters of the competition, and something that was functional and easy to hold. But how? Alright guys, we gotta make a multi-tool, but it's gotta be able to do all of these things. We also want it to be portable, easy to hold, something you'd want to take with you everywhere. What do you think?
Cell phones?
Great idea, Mike. Let's see how we did. Our first prototype had 4 components that allowed it to extend from a rectangular cell phone-like shape into a usable and ergonomic handle. It featured an axe blade, a hammerhead, a plier, and it had lots of room to add more features.
Wow.
Our second design added in the seatbelt cutter with replaceable blade, wire strippers, and a hex mate complete with storage for the bits.
That's pretty neat.
By the third design, we really started to focus on the printability of the part. Not all of the features made it into this print, but it's a start. We added some chamfers, locating features for post-processing, and we changed the position of the hinges so that it was printable without too many supports. Easy. Now we just print it in metal, right? Oh. Okay. We had sharp inside corners at the joining points of the handle and the hinge sections. We suspect that the cracks were caused by varied cooling rates from the different thicknesses and the large contact area between the parts and the build plate, which caused internal stress. We also found it difficult to remove the powder from the deep bit channel storage, and the parts didn't move together that smoothly. Okay, let's try again. To fix the cracking issue, we added lots of chamfers and fillets at the joining points, and changed the print orientation to reduce the stress on the parts enacted by the build plate. This meant that the supports would crack and break away from the plate instead of the parts.
Yeah, that makes sense.
We also added more clearance at the mating surfaces, a lattice structure for lightweighting, and fixed a few features like the hex mate, the pliers, and the wire cutters. The final design is made up of 4 main components, with 3 pairs of press-in-place printed hinges, 2 prefabricated set screws, and 1 safety blade. There are 4 custom-printed bits for the hex mate that are stored in a compartment on the handle and held in place by magnets. How did we make it? It was printed and depowdered on the EOS M290. It was stress-relieved in the oven, cut off the build plate in the EDM, and the supports were manually machined off in a Bridgeport mill. It was cleaned up with some Scotch-Brite. We sharpened the axe blade on a whetstone. Then it went back into the oven for hardening, and then the hinges were pressed in place. Alright, time to test it. Phillips, check.
Look at that. Yeah. That's the easiest Phillips I've ever put in my life. Wow, look at this, Fraser. I like this handle on the screwdriver.
Yeah, we didn't think about it.
Flathead, check. 1/4 inch Allen, check. Tighten a hex bolt, good to go. Socket extension, check.
Oh, we can work on a car with this, you know.
Opening a paint can, check. And closing the paint can.
Right on your new shirt.
Cutting a wire and stripping a wire, check. Hammering a nail, check. Breaking glass, check. It also cuts wood, isn't that cool?
That's tubular, dude.
And the final steps. A safe ride to UPS. A sad goodbye. And we successfully shipped before April 1st. And that's all we got. We'll see you at Rapid.